All right, proving triangles similar. This is chapter 7, section 3. We're not going to do proofs, all right, but we do need to be able to prove that they're similar. Remember the two things that make triangles similar. Their angles are congruent, all right, and their sides are what? Similar. Sides are similar. Okay, that means they're proportional. I can write it this way. Proportional. And you can't read that, I'm sorry. They're proportional. Similar. Similar means proportional. No, it doesn't. I can read it better. Proportional. Okay? That means that we can do the cross, multiply, and divide by setting out the proportionality, and they all should come out equal. So if I have, and you did, part of your assignment was like this, 24 over 30 equals 16 over, I don't know, 20, all right, whatever it might be. If all those are equal, after we reduce them down, then we know the sides are proportional. And that's the other way we can tell whether triangles are similar. All right, so what do we have to do to prove this? Well, we have to take a look and say, just like we did on the last assignment, we have to check to see, in this case here, all they're giving us are the sides. So are our sides proportional? In this case here, we would be looking at this side to this side, and then this side here to this side here, and then this side here to this side here. All right? So we would look at it as 6 over 4. Is that equal to 7.5 over 5? Is that equal to 9 over 6? Now you can reduce it if you want. What's another easy way to do this? Use a calculator. Yeah, just use a calculator on this and be able to say, is 6 divided by 4 is what? What's that on your calculator? $1.5. Is that equal to 7.5 divided by 5? 1.5. Is that equal to, and that is also 1.5. 1.5. So if I looked at, and I just used my calculator to figure out these three, and if I did that, I would see each side is proportionally the same. So then these two triangles, ABC and XYZ, triangle ABC is similar to triangle XYZ based off of the information they gave us. Right, we were able to determine that those three were proportional. In the assignment, you are going to get something also where it might throw an angle in there. The angle is going to tell you what sides are going to be we're going to be working with. We've got two different triangles. One is flipped over, all right? So we're looking at this angle here and this angle here. So A is going to be associated with Z. That's the way we have to figure this out. We have to determine whether these triangles are similar. Well, we already know one angle similar. We know these angles here are 90 degrees, right? So those angles are similar. Well, a triangle is only made up of 180 degrees. So if two of the angles are similar, the third angle has to be similar also. All right? So if they're similar triangles in that respect, they would be similar. postulate used. This is going back to past chapters. If you remember what we said, if two angles of a triangle are congruent, then the triangle is congruent. If two angles in a side are congruent. In this case here, we're going to say similarity. If two angles of a triangle are congruent, then the triangles are similar. All right? That's where you would use it here, the two-angle theorem. I'm not worried about you naming the postulate or theorem, all right? I'm worried about you telling me that this is a congruent, that these are similar triangles right here. This one here should be fairly easy. We're finding the proportion on each side, and if each of the proportions are equal, we're good to go. All right? What would this be? Number 3. What kind of triangles are those? Equilateral triangles, right? Equilateral triangles. What are degrees on an equilateral triangle? 60 degrees. So we know our angles are all 60 degrees, right? We know our sides are all the same. For each triangle, they're just similar to each other. So this, again, would be similar in here. All right, that's part of what I want you guys to do on that. Is that hard to see? Any questions on that? What has to be done? You have these 3 to answer down here, and I want you to think about equilateral triangles. We just talked about that. Isosceles triangles. Can isosceles triangles be similar? Or are they similar all the time? And the last ones, are all congruent triangles similar? All right? 7, 8, 9. So those are going to be more the word representation of it. Is that the only one? Well, you guys got off easy. All right? That's what you got.